Given the rth term of a sequence, this is equivalent to the nth term, it's just in terms of r. I have to write down the first 6 terms. So it's actually the powers of 2, but I'm minusing 1 each time. So when r is equal to 1, I'll get 2 to the 1, which is 2. I'm going to just write down the powers of 2 first, and then I'll minus 1. So 2, 4, just keep times them by 2, 8, 16, 32, 64. Which means for our sequence, we'll get 1, 3, 7, 15, 31, and 63. Then asked to verify that AR plus 1 is 2AR plus 1. So I can substitute in for r plus 1 into the formula up here. We're going to get 2 to the r plus 1 minus 1. Now, it might also be worth just thinking about what this term is, and it's going to be 2 times 2 to the r minus 1 plus 1, which when I expand it is going to be 2 to the r plus 1 minus 2 plus 1. And that will help me then factorize back to get the expression I want over here. So I can write it as 2 to the r plus 1 minus 2 plus 1, because I know that's the result I need. And then I'm going to write it as 2 times 2 to the r minus 1 plus 1. And now I can write it as 2ar plus 1. So you don't have to just start from the left-hand side and get, well, I have started from the left-hand side and got the right-hand side, but I've used the right-hand side to help me along the way. We're now asked to sum the first n terms of this AR. So it's going to become the sum from r equals 1 to n of 2 to the r minus 1. This is in a bracket. Now, when you do a summation such as this, AR plus BR, and this in a bracket, then you can actually sum it separately. It's going to be the sum of AR plus the sum of BR, because if you think about it, you're just going to get A1 plus B1 plus A2 plus B2 and so on, and you can just separate it out so you're just adding your A's and you're just adding your B's. So I can do the same approach here. Sum of R equals 1 to N of 2 to the R minus the sum of 1 R equals 1 to N. Now, if N was equal to 3, then it would be just 1 plus 1 plus 1. I'd get 3 as my answer. Actually, I'm adding n lots of 1 here, so I just get n. Then the slightly trickier one is this one. I'm just going to write out the summation. I think that is a good idea to get a bit of a feel for it. I know it's a geometric series, so I'm going to get 2 plus 4 plus 8 all the way up to 2 to the n. But be careful, because when we deal with the general case, we get a plus ar plus, and then the last term is actually ar to the n minus 1. So we can't just blindly go into this setting a equal to 2 and r equal to 2. We need to, if we want to use this formula, Sn is a 1 minus r to the n over 1 minus r. We need to get it in this form. And so what I can do is factorize out the 2 to give 1 plus 2 plus 4 and then up to 2 to the n minus 1. Now it's in the right sort of form. So it's going to be 2 times a is 1, and then r is 2, so 2 times 1 minus 2 to the n over 1 minus 2. We've got like a negative down here, so it's actually going to become 2 times 2 to the n minus 1. And so my final answer for the sum r equals 1 of an is going to be 2 to the r plus 1 minus 2 minus n. I know I'm running out of space here. I'll open up some more space in a minute. I'm just going to try and fit d in down here. So we're asked to show that 1 over a r plus 1 is less than a half times 1 over a r. So 1 over a r plus 1 is equal to 1 over 2 ar plus 1 from using b. And then here, this number makes the fraction smaller when you add one to it, like a quarter is less than a third. So this will necessarily be less than 1 over 2 AR. And that is actually the same as a half times 1 over AR. So I don't know if some words of explanation are expected, but that is our derivation. That is less than this. One other way of proving D is to start with B and say that, well, because AR plus 1 is 2AR plus 1, then it must be greater than 2AR. And now if I divide by AR plus 1 and divide by 2AR, then I'll get 1 over 2AR is greater than 1 over AR plus 1. We can do this because we know that the sequence is strictly positive. And from that, we can also get the same expression. And essentially, if you have positive numbers like 4 greater than 3, if you take the reciprocals, then actually it just swaps around. For the reason that I've just said, because we can divide by 4, divide by 3, and then the result follows. As soon as you start having negatives, you have to think about changing the sign. There we go. That's another way to do part D. On to the last, and I think the trickiest part. We're asked to hence show that this summation is less than this summation. Okay, well, we have that the sum r equals 1 to n of 1 over AR is going to be 1 over A1 plus 1 over A2 and so on. Now remember, we've already worked out the first 6 terms of this sequence. We had 1, 3, 7, 15. So I'm going to get 1 plus 1 over 3 plus 1 over 7. Okay, but now, oh no, actually I want to write a few more down. So 1 over 15 plus 1 over 31. However, we've just shown in the previous parts that we had that 1 over AR plus 1 was less than a half times 1 over AR. And now we can see some powers of half up here. So I can actually write this as a half over AR. And what follows is that we can write down that 1 over A4 is less than a half of A3. And remember, A3 was equal to 7. So this is a half over 7. 1 over A5 is going to be less than a half over A4. But remember, that was less than a half times a half over A3, which is a half over 7. So this becomes a half squared over 7. And that should be sufficient working to say that this summation here is going to be less than 1 plus a third plus 1 over 7. I've just shown that 1 over 15, because that is what this one is. 1 over 15 is less than this. So I'm going to get a half over 7. And then this one here was 1 over 31. So this is going to be a half squared over 7. Oh, sorry, that then becomes a quarter. And so on. So as required, the question is that convincing enough? I think it's only 2 marks that we just have to show roughly where these ideas are coming from. Before we move on, I'm just going to share one other way to do part E. This is how I did it, although Gotta admit, I've tidied it up a little bit from what I actually did, and I've realized I made a mistake along the way. So I wrote down that the sum from r equals 1 to infinity, and I just want to point out actually that this here should have been infinity as well, because it is an infinite summation of 1 over AR. Now remember, that is equal to 1 plus 1/3 plus 1 over 7, okay, as shown before. Now, another way of writing it is to substitute in the nth term and write it as 2 to the r minus 1. And then what I did is, like, I noticed that these three were the same in this part of the expansion. So I wrote those out, 1 plus 1/3 plus 1/7. And I started from r equals 4, because this is where the inequality essentially begins with these. So let's focus on this. So I decided to factorize out 2 to the r minus 3 from this. The reason being is that then we get 2 to the 3 here, and I could see that links into a little bit to 7 because I'm at 8. And then I also factorized it away from the 1, so now I get 2 to the 3 minus r. And what I can do now is, because I'm dividing by 1 over 2 to the r minus 3, I can put it at the top and write 3 minus r here. And you can see we're going to start getting our powers of a half up here. So when r is 4, we're going to get a half. When r is 5, we're going to get a quarter. Then this becomes 8 minus 2 to the 3 minus r. So 8 minus 2 to the 3 minus r will actually be greater than 7 for r greater or equal to 4. Because when r is 4, I'm going to get a half here, 8 minus a half. When r is 5, I'm going to get 8 minus a quarter. So it will always be greater than 7, which means that 1 over 8 minus 2 to the 3 minus r will be less than 7. I'm doing that little reciprocal idea again, or equivalently divide by 7, divide by 8 minus 2 to the 3 minus r. Because this is true, then that means that this will be less than the sum from r equals 4 to infinity of 2 to the 3 minus r over 7. And that there is equal to a half over 7 plus a quarter over 7 plus an 8 over 7 and so on. And therefore the result follows. I haven't quite put it all together, but remember I had the 1 plus a third plus a 7th already. And I've just shown that when I then add the 1 over 15 plus 1 over 31, it will be less than 1 plus 1 over third plus 1/7 plus this thing here. So it's a little bit more intricate, but I feel like it's actually a bit more rigorous than what I did up here. Because I kind of did it up here and just said, hey, it's going to carry on. Whereas here, I've like actually shown it's, quite comprehensively that this is always true. On to the very last part to show that this summation lies between two fractional limits. I'm not actually going to work out the exact answer, but we want to get a lower bound and an upper bound, although it can actually equal the lower bound. It's got to be greater than that, but less than this. So one thing that we can write down, remember this here is equal to this. So it must be for the lower bound that what for the sum from r equals 1 to infinity of 1 over AR is going to be less than the first three terms because remember, I'm then adding more. And the reason that you might think to do this is that look, it's over 21, and the lowest common multiple of 3 and 7 is 21. So this becomes 21 over 21 plus 7 over 21 plus 3 over 21, which gives 31 over 21. And we've actually got our first result very quickly. That is going to be our lower bound. The upper bound, well, we have it from part E that the summation is going to be less than this. So if I focus just on this part, there's actually a geometric series. So I can take out, let me call this bit star. So then star will equal 1 over 7. I'm going to factorize that out. Then 1 plus a half plus a quarter, and so on. So if I just consider this bit, then I've got a equal to 1 and r is equal to a half. So the sum to infinity is going to be 1a times 1 minus r, so just 1 minus, sorry, no it's not, what am I talking about? It's the sum to infinity in general is a over 1 minus r. So here it's going to be 1 over 1 minus a half, which gives 2. And therefore star is actually going to equal 2/7. So using E, the sum, which is this thing here, is going to be less than 1 plus a third plus this star that we've just found 2/7. And we're into a very similar position now. It's just instead of 1/7, we've got 2/7. That's our upper bound. And that's going to be, again, 21 over 21 plus 7 over 21, but this time 6 over 21. And this gives 34 over 21. So that was why that part E was so useful. And the result then follows. I could write it out as a single inequality. Do you know what? I think I will. It's a really good question here. We've got geometric series going on, but then we take the reciprocal. We can still use different facts. We've got to think about summation notation, all sorts of things, but we get this pretty neat result at the end of it. Brilliant.